Some of you guys may know me. Run my mouth on Twitter because I have adult ADHD, and that's just exactly my drug of choice. I'm now hanging out on Mastodon, but I haven't left Twitter either, so you guys may know me from kind of either place. More importantly than me running my mouth too much and having been around data stuff for a while is let's see, I was born in 1972. So Christmas of 1980, I was 8 years old and stuck under my bed in the place that would later hold Victoria's Secret catalogs, was actually stuck at that point in my life, the Lego catalog. And the Lego catalog was dog-eared, and this was the Lego kit that 1980 version of me wanted more than any. This was my Red Ryder BB gun of 1980. And in Christmas morning 1980, I came downstairs and Santa Claus had brought this Lego kit, and it was the apex Lego experience of my life. And I'm not even sure if my parents know this, but I'll make sure they watch this video and know this. And actually, my only regret was every other Christmas for the rest of my life has been somewhat of a disappointment compared to getting this kit with the actual motor, and it changed gears and it even went in reverse. And I was 8 years old, right? So by the time I got in middle school and taking physics class, I thought that the people who thought the engine spun in the other direction when you put it in reverse, I thought they were brain damaged, because that was beyond intuitive to me, because I had been building actual little transmissions with gears since I was 8 years old. Anyway, I mentioned Lego and Lego being the apex toy because, much to my pleasant surprise, last year in Nature magazine, Adam, Converse, Hales, and Klotz had a paper that had a Lego example. They did actual work with humans, and it had a Lego problem in the middle of it. So I'm immediately interested, because we know Lego are the apex toy. So in their paper, they gave participants in a study the Lego arrangement you see on the left. Actually, it wasn't a Lego minifigure. They had a Star Wars character, and I'll show it to you in a minute in the next slide. When it got published, for copyright reasons, they couldn't put the Star Wars Stormtrooper in there. So I think actually I got the paper right here. I think they do just a little drawing with figurine removed. But anyway, it looked like the thing on the left. And what they asked participants first, like they don't even have the figurine in here. It's just a placeholder. What they asked participants to do is said, okay, take this Lego model and make it so that we can put this brick on top of that top part and it not crush the figurine. And that was the first challenge they gave folks. And so you can imagine, and you guys should do this in your head. Imagine you've got these blocks, you've got this figurine, you've got this Lego arrangement. How do you arrange this so you can put the block on, the brick on top of the Lego blocks and not crush the figurine? All right, so think about that. And that's actually how it looked in real life. So like the next cycle of this, they say, okay, we're going to give you $1 to solve this problem, but each additional block costs 10 cents, and it's got to hold this brick on top. So think about how you might solve that. All right, so you might, put 3 more blocks on there. You'll be down 30 cents, still make 70 cents, right? There's other ways you might have solved. You might try to put just one in the corner and hope they put the brick on really square so it balances. Anyway, they also, in a third round, prompted people with just the phrase, removing a block has no cost. Now think about this yourself. How would you have solved this Lego problem if I prompt you with removing a block has no cost? Now, I wish I could see the whole audience. If you're in the chat over here, I've got the general tab open. Let me know if you changed your mind when I said removing a block has no cost, because a huge number of respondents in this study did. because the default action was to think about adding something. And they discovered that it was only through prompting, and they had to do pretty strong prompts, they could get people to think about removing, and people would see it. And then they would begin to choose subtracting. And it was kind of like the big surprise of this whole paper is additive ideas come to mind quickly and easily, but subtractive ideas require more cognitive effort. So they decided to test this with a bunch of stuff that boringly weren't Lego blocks. I don't know why, but they tested it with things like recipes. So if we give people a recipe and say, how do you make this better? Almost nobody removes something from the recipe. What they do is they add something. The exception to that is if they had something ridiculous in the recipe that folks will be like, oh, right, yeah, remove that. That doesn't belong, you know, something savory doesn't belong in the dessert, right? Like it would be better if you subtracted that. But outside of kind of the ridiculous, people don't see subtracting something from a recipe as a way to get it better. And trust me, every recipe that I have ever made that I got offline, after I made it, I'm like, half this crap, we don't need it. And we can simplify it dramatically by just like not doing all these steps. It's almost like they think people won't enjoy it if they don't do a lot of complicated steps. Similarly, the study took that this nature and mentioned in this Nature paper, they took a bunch of vacation plans and put them in front of people and said, make these vacation plans better. And most folks' default is to add an activity. Now, my wife and I would have had that tendency, and we had a kid who is now 15. And we later learned, you know, we have a lot more fun if we try to do one thing in the morning and maybe one thing in the afternoon, but make the thing in the afternoon like optional so that like no charge to cancel so that we can punch out if things start going bad. Like that's how we discovered how to have happy holidays and good vacations. But if you give people just an agenda, they will try to shove more stuff into it. And it's because this is human nature, which as I looked around and thought about it, I realized I see this kind of everywhere. And this is a little bit like getting a new car of a certain type. You will begin to see these everywhere. Once I have primed you for subtractive thinking is hard and people don't tend to do it, you will begin to see this everywhere. So that's my Santa gift to you all, is introducing this idea of subtractive thinking and allowing you to see how hard it is, but that there's great benefit. So let's look at a few examples, other things of where subtractive thinking comes in play. Or as my 15-year-old daughter says, cool story, bro, but why do we care? Well, we have already seen mention of this minimum viable product diagram, at least in the chat. I don't know if it made it into one of the presentations. But for those of you who haven't seen it, the general idea is if you design products, you know, incrementally where they aren't useful until you get to the very end, basically your customers are unhappy with you the whole time until the very end, except the reality we all know is at step 4, they look at you because that was not what they wanted. Right. So actually, it doesn't even work this way. This is like a stylized positive version. The real way is, or sorry, the MVP way that Henrik Keinberg recommends in his What is Scrum is this thing that's become iconic, where you give somebody, you know, a skateboard and they're not super happy, but you give them a little bit more and it kind of becomes useful. And it iteratively, we add a couple more features and we get iteratively more useful, but they don't hate it all the way through. Well, what is this exercise other than reducing down what is the minimum thing we can give somebody that they get positive utility from? I just slipped into economics talk, but that they're somewhat happy with. What is the minimum thing we can give them? And then we ask, what is the next marginal improvement? Oh my God, I did it again. What is the next marginal improvement that we could make on this thing to make it a little bit more useful? Okay, so this is this exercise in reductive subtractive thinking where we are trying to figure out what's the least we can do to make the most positive value. So the whole minimum viable product exercise is really just to try to trick your brain into subtractive thinking. Some of you may see, I gave a presentation some years ago on empathy, and I presented the thesis that in Agile, the user story, what that really is a hack to get you to be empathetic with a specific user, right? But we make it a specific user, we narrow down what it is we're talking about, and we introduce this hack of the user story, and it forces empathy. It becomes a forcing function for empathy in the mind of a software developer. I think the minimum viable product is a forcing function for reductive thinking that we interject into our development processes in order to prime and pump us for this effective way of thinking, which is reductive, when what our brains kind of want to do is be additive. So it's a subtractive prompt. And remember, from our first part of this presentation, prompting is incredibly important because we're actually open to subtractive thinking. We're not morally opposed to it. It's just not like our default mind state. And so having prompts is super useful. And I think that's why the MVP, part of why the MVP model has gotten so highly adopted, is it's effective because we're responsive to prompts. All right, so let's think about more reductive things. A few of you may have seen my comment online where I talk about reading through an answer on Stack Overflow, and please ignore my spelling errors. And I thought, wow, that's a really great answer, and I really learned some things. And I got down to the bottom, and I discovered it was my answer that I wrote 8 years ago. All right, so besides being kind of comically silly that I would read something I wrote and not even recognize it as my own writing, one of the things that this reminded me of is the way I ended up writing so much on Stack Overflow was that I just happened to be there when it started, and I was just learning R as Stack Overflow was starting. And one of the things a handful of us did, and actually, Chris, I had forgotten you were involved in this because I found notes relatively recently, and I had completely forgot. Like, I didn't know you then. And by the way, longtime listener, first time caller, this is the first time Chris and I have ever talked in real voice, although we have traded messages on and off over the last years and years. But Chris was there, Mike Driscoll, who's with Real Data, Real RILL Data, and they just launched product this week. Mike Driscoll and I helped prime Stack Overflow with R questions because there weren't many R questions, and we felt like the R discussion list online, the email list, was not super helpful for learners. And so we got a bunch of questions that had been asked on other R discussion forums and things that had been put into a search engine of a popular R site. And we turned them into questions for Stack Overflow. And then we just divided it up. A bunch of people posted questions, a bunch of people answered questions, and we seeded the R tag on Stack Overflow. So I was sort of there at the beginning in a bunch of ways, and I haven't answered or asked a Stack Overflow question in years. But I was real active early on. And one of the things I did is every time I was learning something, it was R, then later it was Pandas as I began to use more Python as Pandas came on. And I started to ask more questions. And I had developed the skill of reducing my thinking and my question down to something fairly specific. And that allowed me to answer a good question that could be answered. And over time, this got a name. This began to be called a reprex, or a reproducible example, and began to be called that. And as a matter of fact, Jenny Bryan, who did one of the lightning talks about naming things, Jenny Bryan has a library for R called Reprex for helping make these easier to make. Reprexes are an exercise in reductive thinking. They're unreasonably effective because when you write a reprex, it's a type of debugging. If you have a problem and you're writing a reproducible example, it is akin to rubber duck debugging in that the process of reducing your question down to a minimum viable example, you actually a lot of times, discover what I was doing wrong or what the problem is before I ever answer the question, because I get all the noise of everything else I was working on out of the way, and I get down to the brass tacks of what the problem is. And then I'm like, oh, dumbass, there it is. And it just jumps out at me. Now, sometimes it doesn't, and I'm able to share it online on Stack Overflow with my team in a Slack, wherever, and somebody else can just copy, paste it into their editor, run it, and be like, oh, dude, here you go. Here's what's going on, and like, oh, I see now that, matrix was shaped the opposite of what I thought it was, or whatever. So you can get more eyes on the problem quickly because you allow someone else to understand your problem more quickly. That's reductive to get there, and it's hard. It's got to be explicitly taught, right? When analysts come in and start working with us, they often sit down with me with a problem that is too complicated for me to understand what they're doing. And they're a little surprised because they've got this whole course of knowledge problem. They understand what's going on the screen. They can't believe that I can't, because I'm smarter than them from their point of view. I should be able to understand it. And so I always give them as a challenge, hey, let's do this as an exercise first in reducing and focusing your question down and creating a reprex. So I'm a huge fan of reprexes as a type of reductive thinking. Now, I went through this exercise recently with Coiled, who they're a company that supports and employs a number of Dask contributors. And I had a Dask problem that wasn't working well. And we actually hired them to come in where I work and partner with us and work on a problem we had. And I've shared this story elsewhere, but at the end of it, they said, hey, this was kind of an interesting problem, and showed a limitation or a challenge in Dask because it was a big, like, unbalanced join, and it was a many to many join. It was just gnarly behaved problem. It just didn't flow well through anything. And they're like, hey, can we have your data, like, anonymize it more and us use it? And I said, actually, no, but I can make dummy data that acts. I think I understand this problem enough to make dummy data that acts like this real data. And I just went in and worked with them, and we created, and this is all public on GitHub, we created a reproducible example of this dummy data set that's got 4 billion records. Now, this is an awful lot what Julia Silge talked about with making simulated data to learn something. Well, I made simulated data to match a real problem, but I did it because I could make it public. And then we could use that as a test against different distributed platforms. I mean, Coiled can use it against Dask. Somebody else may want to play with it against Spark to make Spark better. Great. Everybody wins, right? It's a certain class of challenging problem. But that is a type of reductive thinking. We had to go through the process of figuring out what was it about my problem that made it difficult or hard. And then we had to reproduce that. That was largely a reductive exercise. It wasn't this, it wasn't that. It's only these facets of the problem. And then we created simulated data to represent those parts of the problem at scale. Super useful. So I'm a big fan of Adam Savage. And what could be more normcore than every tool is a hammer? I kind of psychologically made my way through COVID by laying underneath an old Jeep, getting various motor fluids in my face. And part of the time I was doing this, I was listening to Adam Savage's book. And one of the things that really jumped out at me in the book is he talks about buying material to build everything he builds 3 times. So he goes into a build knowing he's going to build it 3 times. The first time you work the kinks out and you just sort of figure out how it works. The second time you get a really good version, but it isn't camera perfect. And he makes props for movies, so it has to be camera perfect. So after the second time, he then knows enough to build it the third time and get it camera perfect. And I think this is part of reductive thinking, is not planning the first time we do something to boil the ocean. And that was mentioned in the presentation right before me about not trying to do everything. Like, just get your logic flowing through a system and then figure out where your performance bottlenecks are. That's a certain type of reductive thinking. So to repeat myself, subtractive or reductive thinking is not our default. It's hard. Prompting to think subtractive helps considerably. We can be prompted. MVPs are a great prompt to think about reducing or subtracting things. Reproducible examples are a critical meta skill that are reductive. Refactor for simplicity, reduce it down, is a really good use case of subtractive thinking. And even taking out code and using a library that someone else maintains, that's even subtractive thinking. So on that note, I'd listed some job openings. They're also in the chat, in the Slack. So let me stop sharing and we'll do Q&A.